Okay, my friends, let's work on the lab report. First thing I want you to do, download the lab report from the link right up above you here. I made my own version. The official way is to go into the lessons and download the graded assignment there. I reworded this question because the way they had it was based on how we used to do the lab, where we would measure how long it took to dissolve something, and we don't do that anymore. Okay, so first question is, on the basis of your results, what is the relationship between the temperature of the solvent and the amount of solvent it can dissolve? Okay, so this is the sort of answer I want you to put. From my results, I can conclude that the temperature of a solvent and the amount of solute it can dissolve have a, here's where you have to choose, direct or indirect relationship. You tell me which one it is. If it's direct, both go up or down together. If it's an indirect relationship, then as one goes up, the other goes down, and as one goes down, the other goes up. Alright, so choose which one it is based on your results and tell me. Let's go to question 2. Describe in a step-by-step manner how you determine the identity of the two unknowns. That's the first thing we have to do. So whenever I do a step-by-step thing, I'm going to use bullet points. This has an order, so I'll go ahead and I will use the numbered bullet points here. I'm going to pause the video and write some stuff down. Okay, now I've got some bullet points and I've outlined step by step what it is that we're doing in this lab. So first, I calculated the minimum temperature at which 32 grams of KCl would dissolve. Then I calculated the minimum temperature at which 32 grams of KClO3 would dissolve. Then I calculated the minimum temperatures at which 37 grams of both of those would dissolve. I cooled beakers A and B until I saw solute collect on the bottom. Recorded the temperatures at which solute was visible, and then compared the temperatures of A and B to my calculated temperatures to determine what the solute was in both beaker A and B. That's the step-by-step part, how we determine the identity of the two unknowns. Now we have to do more. Discuss both, so two things, what you determine the unknowns to be. Let's do that first, okay? So, I'm going to start off the sentence like this. All I have to do is say what A was and what B was. So I say I determined that unknown A was, and you fill that in, and unknown B was, and you fill in that part. Okay, so that's discussing what we determine the unknowns to be. We also have to discuss the method that you use to find them. Now this is kind of silly because we just listed the exact method we used right here. I have 6 steps, so this is what you can write for this. Okay, I used the method above to come to this conclusion. Bam. You should not have to write it out again. I don't know why they did that in this question, but it's in the question, which means you have to do it to get full points. So here's the way the points break down. I'm going to give you 2 points for telling me what unknown A was. 2 more points for telling me what unknown B was. That's 4 points. I'm going to give you 1 point for discussing the method. That's 5. We have 7 points total, so you get 2 points for listing the steps. Alright, so 2, 4, 6, 7. That's the way it breaks down. Okay. Let's take a look at very last question. Use your knowledge of collision theory to explain the results of your experiment in this laboratory. Problem with this question is that A, you really haven't learned much about collision theory at all. It's in one of your lessons very briefly. And B, collision theory usually is used to explain the speed of chemical reactions, not solubility. So I'm going to give you a sample answer here that you can use as a guideline for your answer. I don't want you to copy it down exactly, but I do want you to use it as your guide. So reword it. Don't use the exact same thing. And it's actually in the walkthrough. No, it's not in here yet. Okay. I'll put it in there. Hold on while I type it in here for us. Okay, looks like I had it in here, I just had it in the wrong place, so I moved it around. Here's the sample answer for question 3. We're using collision theory to explain the results of our lab. And our lab shows us, based on temperature, how much solute a solvent can dissolve. So, here it is. First, let me just explain collision theory in a nutshell. Collision theory is the idea that chemical reactions occur when two molecules collide with each other. Here's what your answer should be like. Okay, first, I want you to tell me that solutes dissolve when solvent particles collide with them. It's that collision that causes the dissolving process. Second, tell me that at higher temperatures there will be more collisions due to solvent particles moving faster. Don't tell me exactly that, but tell me the same thing in different words. And third, tell me that increased collisions lead to more dissolving at higher temperature. Okay, so 2 points for telling me that you dissolve because of collisions. 2 points for telling me that higher temperatures lead to more collisions. And then 2 points for telling me that those more collisions lead to more dissolving at higher temperatures. Right, that's what that question is worth. It's worth 6 points. So give me all 3 of those things in your own words or in different words, and you've got full points.